Okay, so now it's my turn to reach through the tripod and write, which is always a little dangerous. But here we go. Square root of 5 is a over b. Okay, so same thing. B squared times 5 equals a squared. Just what you did. Square both sides. Multiply by 5.
Okay.
But instead of using the divisibility by 5, I'm going to try to do the odd and even argument.
Okay.
So what can you tell me about A and B? They're in lowest terms, but what can you tell me about their oddness or evenness?
Well, I mean, if b squared was even, then a squared has to be even, because even number times anything is an even number.
Okay.
And if it's odd, you're multiplying it by an odd number, so it stays odd. So they're the same oddness or evenness.
Okay, and since they're in lowest terms, that's going to imply something.
That they're both odd.
Why can't they both be even?
Because then you could divide out a 2 from them.
Okay, so following the odd and even argument from the square root of 2 proof, we see that actually in this case they're both odd.
Yeah.
Okay, so we can write A equals 2x plus 1, and B equals 2y plus 1. Okay, so what is 2x plus 1 squared?
4x squared plus 4x plus 1.
Okay. And b squared is going to be the same.
Yes.
Right? Okay, so I'm going to have 5 times 4y squared plus 4y plus 1 equals
4x squared. X plus 1.
X plus 1. So this is going to be 20y squared
Plus 20y.
plus 20y plus 5
Yep.
plus 4x squared plus 4x
Plus 1.
plus 1.
Okay.
Okay.
Alright.
Is there anything we can say here?
Well, if you tried to move some of the terms to one side, you could maybe subtract 1 from both sides. Just get a 4 here.
Okay. That's nice.
4, and it looks like you can divide by 2. You can divide all the terms by 2.
Maybe you can even do a little better than that.
And you can divide all the terms by 4.
Yeah. So we get 5y squared plus 5y plus 1
Equals x squared plus x.
x squared plus x.
Alright. 5y squared plus 5y plus 1 equals x squared plus x.
Alright, so yeah, this is actually a pretty interesting situation we found ourselves in. Okay, so let's do the same thing, the odd and even argument with y and x.
Okay, so well, now we don't know for sure if, well, because we don't have this x over y relationship, we can't like say.
Right, that's a good point. We don't know anything about x and y. They might actually have a common term somehow.
Okay.
But let's stay with odds and evens. So what happens if y is, pick one, even or odd?
Y is odd, then this term is odd, this term is odd, so I remember is even, plus 1 is odd.
Okay.
Y is odd, and then x squared will be odd, and x, so this has to be odd, but if x is odd in this case, we get odd plus odd, which is even.
Okay. So we've ruled out, so this is y and this is x. Here's my chart. So odd
Odd is ruled out.
can't work.
And then odd even won't work either because
Odd even.
you get the same thing. You get odd and even plus even.
Alright, that doesn't work.
So let's see, even odd. So if y is even, this term is going to be even, this term is going to be even, and this term makes it odd.
Alright.
And then even odd, you get odd plus odd is even, and even, you'll get even on this side as well. So you get, no matter what, you'll have this side has a different oddness or evenness than this other side.
Yeah, so it's a real interesting surprise that this proof works.
Yeah.
So this side's always odd, no matter what, as long as
Yeah.
y is an integer, and this side's always even, no matter what, as long as x is an integer. That's wild.
Yeah, it's sort of the same proof by contradiction thing. You find something that doesn't make sense, and that means your original assumption was wrong.
Yeah. So let's talk about this for one last video.